All right. So hello, everyone, and welcome to this one-off meeting on per volume CSI capabilities as part of the Kubernetes SIG storage group. If this meeting may turn into a series if we have enough to discuss, but I just wanted to have this kickoff meeting to collect the use cases and brainstorm solutions here. I have been talking to Hemant offline about some of these problems. It's come up in the Kubernetes SIG storage CSI meetings. It's come up in the CSI community meetings. So there's been a bunch of different forums where we've sort of hinted at what the problem is, and I wanted to get everyone together and just sort of write down what all of our use cases are. And I'll start with my own use case that I've put here in the agenda. So the issue that's long plagued us is the FS group policy option, where for iSCSI volumes, it makes sense to do a recursive chown if you need to change the FS group, but for NFS, it doesn't work. And so if we had an iSCSI only driver, we would set the FS group policy to use the feature. And if we had an NFS only driver, we would set the FS group policy to not use the feature. But the driver that we have actually supports both protocols, and there's no way to sort of signal to kubelet on a per volume basis what it should do. And we've thought about a number of ways to work around this, including CSI spec changes, and we never really arrived at a satisfactory conclusion, partly because this is already in Kubernetes as a sort of a non-CSI extension. Right, the CSI driver object in Kubernetes is actually not part of the CSI spec. It's totally Kubernetes specific, and basically enables drivers to tell Kubernetes to do specific things that are outside the spec. And it's been working reasonably well, but this is one problem where it sort of fails. So I would be open to maybe changing the way that it works so that on a per volume basis, a CSI driver could tell Kubernetes something that makes it look at different CSI driver objects potentially, right? There could be a default CSI driver object, but then there could be a per volume one that had different options. Or we could enhance the CSI spec to just specifically communicate the override values for on a per volume basis, and just solve this inside the CSI spec. But right now there's really no information at all that comes back on a per volume basis. So we have to add something to the CSI spec to sort of add a hook that then kubelet can see that it needs to do something specific. And that's the use case that I care mostly about. I see that Humble wrote a response that I haven't read yet, so I'll read it real quick. Mentioning different values for iSCSI volumes. Do we have Humble here? I guess this is a time that doesn't work for him. I don't see him. And I'm not sure what his criticism is from this large paragraph, but it's okay. At the end, he says, if the requirement is really to have it per volume, I expect the current volume attribute on the CSI spec to accommodate that. So yeah, one way to do it is just extend the CSI spec to specifically address this use case. I was thinking of something more flexible where maybe you could return like some sort of a volume type key that would key into something in the CSI driver that then Kubernetes could look up, and you could continue to do the out of spec style thing that Kubernetes currently does, where it's basically proprietary. But I could go either way. As far as solving my problem, but I would like to come up with a general scheme that addresses everyone's problem. So Sandeep, can you describe your use case? We can see how similar it is.
Yeah, sure. I can describe the use case that we see here. Uh, so yeah, I'm basically from VMware, and we have a driver called vSphere CSI driver. That single driver supports both read-write once and read-write many volumes. And we have seen some challenges with respect to the capabilities that we need to expose. For example, one use case that we have is there is something called max volumes per node that we need to set in a node get info response.
Yeah.
So that is used by Kubernetes to actually limit how many volumes of this CSI driver can be attached to that volume to that node VM. So because we are implementing both read-write once and read-write many, it's a challenge for us because like on our side the limit is you can attach a maximum of 59 block volumes, read-write once volume to a VM. Whereas for read-write many, these are NFS mounts. Like there is no really not really much of a limit there. So you can even go beyond 59 or whatever it is. So now we have a problem where we have to either set it as 0 or something. I think if you don't set it, then it assumes that there is no limit. If that happens, then there is a problem. If at all, like a lot of stateful workloads land on a particular node VM, if it goes beyond 59, then things start failing. So that's a problem. And if you limit to 59, then we cannot scale the number of other stateful workloads like read-write many ones. So I think the requirement that I'm seeing here is if we can have a capability in CSI spec itself that says per access mode. I mean, I'm not looking per like volume, like per volume type. If we can say what is the maximum volumes it can support per node, and if we can make that changes wherever necessary in the Kubernetes stack, like even the scheduler should be able to look at the access mode and decide all these things. I think that's one use case I'm saying. At least at the per volume type.
Just on that, I totally understand the problem, and
right.
I don't think that in everyone's case it's going to be tied to the access mode, because one could imagine a scenario where you had, even within the same access mode, different kinds of volumes, some of which had a higher per node limit and others that had a per node limit or lower per node limit. And so I can't remember when we designed the node limit feature, the node volume limit feature, if we considered the possibility that like some drivers would have very complicated notions of limits. But this is an obvious example of a real world example where where it does, and that does kind of argue for something a little bit smarter, because there's no good workaround, as you mentioned. If you just set it too low, bad things happen. If you set it too high, bad things happen.
The similar problem will be with the capacity responses also, right? Because the capacity from which read-write once block device is being provisioned, capacity from which read-write many volumes is getting provisioned could be different.
Oh yeah.
So yeah.
I mean, so that kind of argues for it would have been better to have two different CSI drivers for the two different cases. And you could make the same argument about my problem with NFS and iSCSI. It would have been better to make two different CSI drivers, one for iSCSI, one for NFS. I guess the downside to doing that is that you need double the number of sidecars, and your deployment is a lot messier.
I guess, is that something, is that a problem we should consider tackling? Like, I know we've talked a lot about in the past about like consolidating all the sidecars into a single process and things like that, or making a sidecar able to, well, I don't know if that would work, but a sidecar being able to handle two drivers in the same pod.
I think the latter would be better, because the controller isn't the worst part. It's the daemon set for the node plugin that's a tax on your whole cluster that scales with the number of nodes. And if you have to have two plugins instead of one, you've doubled that tax. So to the extent that you could have multiple drivers, in a pod for the node plugin, that would have a bigger payoff than trying to consolidate anything on the controller side. Although we should consider making it less messy to deploy a controller plugin. Right now, I think you need like at least 4 sidecars and more if you do like the liveness probes and metrics and other, well, I don't know about metrics, but yeah, it can get complicated. So that's something to consider for the future, but like we still have the situation where today we already have a bunch of CSI drivers that don't do that are stuck, right? Because for existing volumes, you can't change the driver name. So even if it was easy to split our driver into 2, all of our existing volumes would not be transferable. So that kind of makes it not possible.
Yeah, I think my only concern is that I feel like a lot or almost all of the features we have are all under the assumption that, you know, the single driver only supports one type of volume.
Yeah.
I think to support, you know, the driver supporting 2 types of volumes, we would basically have to revisit every single feature that we've implemented. I feel like that will be a lot of effort to tackle because we would have to potentially make new API changes and, you know, all like every single feature would have to, you know, be revisited.
Well, that's a worst case. That's a worst case estimate. I think in reality, we've gotten a lot of mileage out of the status quo where we pretend that they're all the same and you only have a few rough edges that poke through, I think.
But there's just like there's certain cases which are unworkable. It's just because the driver is some drivers are in a state where like they are not ready for consumption yet. Like for example, Azure file, which is a read write many volume by default. It has a block mode, so where you can specify a FS type and then it gives you a loopback device, which is basically on a read write many Samba share, and you can mount it. So the FS group, how it applied on that volume, that block volume, and how it applies on the regular Azure file is completely different. And I mean, it's basically the volume that you provision via block mode is unreadable in Kubernetes. So,
well, hold on. Can you describe why those 2 things would be under the same driver?
That's how the driver author has chosen to implement it. It's like, if you create a storage class for your file, and you specify a FS type in the, then it gives you a block volume. If you skip it, then it gives you a read write many volume. And the way these 2, even though the driver name is same, the way these 2 volume behaves was like completely different.
Okay, so it sounds like the problem there is we've made it way too hard to just have multiple drivers, and so everyone is defaulting to trying to cram all their features into one driver, and thereby creating a situation where you have many disparate types of volumes under the same umbrella, because we just make it too painful to go ahead and add a second or a third CSI driver for the other use case.
Let me talk about like our like what we went through when we designed this CSI. So at that time, we knew that we had to support both read write once and read write many, like 2 different volume types.
Mm-hmm.
And we did a research actually. Like we looked at CSI spec. We saw like, does the CSI spec say we need 2 separate drivers for separate access mode? And at least the conclusion that we reached at that time, I remember like I even reached out to the community and all that. I don't think there was a specific guideline that you should have one single driver per volume type or per access mode. So that was one of the reasons why we felt, okay, the CSI spec doesn't say anything. I mean, it's quite possible that we can have one driver, have multiple volume types and all that. So that's the reason why we went into this direction. And if we want to revisit that, and if it means we'll have to split this driver into multiple driver depending on the volume type, that it itself going to be a huge effort on our side.
Well, that's one proposal on the table is basically make it much more clear that you should just be using different CSI drivers, and then try to do something about all the existing ones that are already in the bad state. We could at least help future authors not do the wrong thing. But we still have to figure out what to do about all the ones that have done the wrong thing.
So actually, I see there is a field called volume lifecycle modes were added in the CSI driver to let you know, let a driver specify what volume modes are supported, and it's kind of, you can add multiple volume modes. So I feel that that field means suppose the CSI driver should support multiple volume modes.
That was more about persistent or ephemeral, not really access modes.
Yeah, we have access modes, we have volume modes, and we have persistent ephemeral volume types. The word mode is very overloaded.
Yeah, just thinking whether it is a trend for CSI driver to support multiple different type of modes, or like for each individual mode we should have a different driver. If we agree on like it's a trend, we should go, then yeah.
I do feel like if we come down on the side of, you should be writing multiple CSI drivers instead of trying to cram different features into the same CSI driver, like it would be incumbent on us to make that easier than it currently is, especially in terms of the tax on the cluster when you install multiple node plugins. Like that's a lot of RAM per node potentially, to have that daemon set running everywhere.
Yeah, I kind of feel like in terms of just timelines and like timelines and scope of what needs to like be done, I think supporting the latter will get done quicker than trying to fix all the various features.
Well, let's get through the rest of the use cases and see how many features there really are that are hurting people. I've heard the FS group policy is the one that's hurting us. The per node limits is hurting Sandeep. Sandeep, did you have a second case, or is your second bullet point more about the same?
Yeah, I would actually say it's about the same. Yeah.
Okay.
I would also guess that the FS group related stuff, both FS group and SC Linux related features that we're adding will also impact drivers that support both block and file.
Yeah, but I mean, so Kubernetes already has this CSI driver object that we use to basically signal to Kubernetes specific features that CSI spec doesn't cover, and something as simple as being able to have multiple instances of that object per driver, and then to be able to switch between them on a per volume basis wouldn't be the end of the world. I mean, Kubelet could easily just look up, the appropriate instance of the CSI driver on a per volume basis and read whatever value it was going to read. So if we could fix it just for that things that depend on the CSI driver object, that seems like a pretty light lift. It might be weird to have multiple instances of the CSI driver object or to have to change it, but I don't know. I want to hear about the SE Linux use case because I'm less familiar with what's going on there.
Yeah, so the SE Linux, the Jan is working on a proposal where he's working to implement SE Linux as a mount option. So basically it amounts to the same thing. You have the driver defines in CSI driver object if it can support SE Linux as a mount option, because the mount option has to be applied on the first mount at the node staging time. So that capability, whether it supports or not, has to be known to the kubelet before it calls node stage. And currently it's like it's known because we are recursively chconning the file. So it's like we can determine that by how sec level option appears after the mount happens. But in this case, if we have to apply SE Linux as a mount option, because it will be way quicker, then we have to know before. So it's defined as a parameter in CSI driver object. But if, let's say for vSphere, CSI driver has two different types like NFS and the block. Yeah.
But why does Kubelet care at all about this? Why isn't this something that's purely down inside the CSI driver? What am I missing?
Because the SLNX context is determined by the pod, like it's a pod.
Okay. So SE Linux is a context that's shared between the CRI and CSI. That's what you're saying?
Yeah, it comes from the pod. Like the pod defines a SLNS context, and that needs to be supplied to this thing. And if the drivers,
how does it get passed in today through CSI?
It currently CRI is doing this recursively, like it always does it. Like if the kubelet determines that there's SLNS context support on the SLNS support for the volume by looking at the mount, how the volume was mounted during the stage, then it basically stage or publish, then it recursively does the CRI not kubelet, CRI does recursive chcon and first it gets the pod's context, Linux context from the pod, and then it does chcon of the entire volume. That is done by container runtime. We want to move the responsibility from the container runtime into kubelet, so that kubelet supplies, kubelet itself doesn't do it, but kubelet supplies this mount option, the SLNX mount option, to the driver, so that the driver can mount it correctly.
But wouldn't we just do that as a new CSI spec feature, like a new capability in a new field for node stage and node publish?
I think in the camp, that's exactly what Jan was trying to avoid, like adding it to the CSI
spec
APIs.
But why? Why? I mean, why would we try to shoehorn it through an existing mechanism?
Even if we had the capability, it still mean that like for it would be for the entire driver. Even if it would be like we moved it to say CSI driver capabilities on the node, it would still be like for the whole driver. It wouldn't be for the, so it doesn't matter whether it is in the CSI driver Kubernetes object CSI driver, or it's a capability on the driver side. It's still for the whole driver. Whereas
Right. Okay. So you're saying that there's going to be some CSI drivers that can do this, but only for a subset of the volumes that they're responsible for.
Yeah.
And then kubelet needs to know which are which, regardless of how it communicates this down.
Yeah. It's same as FS group, basically. So very similar mechanism as FS group.
Okay.
And yeah.
Okay, but if we address this with like a flag on the CSI driver object, and there was a way to basically get a different instance of the CSI driver object on a per volume basis, then that would address this need, right?
Like theoretically, yeah, it would address the need. Like, but access mod is not the only distinguishing feature. Like I said,
I guess how would you distinguish like which CSI driver to use?
Well, I'm imagining some CSI spec change that when you create a volume, you get returned an additional piece of some key into some table, right? An additional key that says what the volume protocol or the volume type, or some field that we have to identify that would be like the key that you would use to look up the correct CSI driver object, or if we made the CSI driver object contain in itself like a map, then it would be the key to look it up in that map. So then you could have, iSCSI get one key and NFS get another key, or
this would get set during provisioning, essentially.
Yeah, because it would be frozen at creation time, which I think would address everyone's needs, right? Because at that point, you know where the volume is, what kind of volume it is, and what it's going to be able to do, and you would just need to signal back some key that lets you know what kind of volume you actually got, because the problem with the CSI spec as it's written is, you say create volume and you put some capabilities, but like if, for example, if your model is, read write once volumes become iSCSI volumes and read write many volumes become NFS volumes, nobody says anywhere that you can't give an NFS volume for a read write once volume, right? It works fine. Like, you may prefer not to do that, but it's allowed. And so any volume that meets the specifications that were sent into create volume is valid. and the external provisioner sidecar doesn't get to have any input other than the size, the access mode, the volume mode, and then all the parameters from the storage class. And it has to accept what it gets back. And there's too many cases where even with all that filtering, both NFS and iSCSI are still valid, and it's up to the driver to choose what to create. And so, yeah, having some key that comes back from the create that says, okay, you actually got an iSCSI volume now, or you actually got an NFS volume now. And therefore, when you're doing these node operations, you need to use the key that's iSCSI specific or NFS specific. That would satisfy the need. I don't know if that's what the direction people want to go in, but I'm able to convince myself that at least it's technically feasible. Now, none of this addresses Sandeep's case of like node limits, right? Because that is a CSI feature that's built into the spec, and it's considered to be a global value for the whole driver. And we would have to redesign the CSI feature to address his case, I think.
He had another use case of publish list volumes, I think, where the publish volume IDs, it's not possible to do that for read write many volumes, where it's possible for read write. It's not possible for read write many, but it's possible for read write once.
Right. Okay. The list published volumes or list volume published nodes.
Yeah.
Can work sometimes, not other times.
Yeah.
That doesn't surprise me at all. Although there are ways to work around that by just making your driver store more state, which is what we do. You can just store the state inside your driver so that you know which nodes a particular volume is published to, and thereby implement the feature with the current spec. Yeah, it would be weird just to say, well, you can get it for some volume types and not other volume types, because the consumer of that feature is the external attacher sidecar, and it's reconcile function that happens when you start up the sidecar, right? And for the reconciler to only be able to reconcile half your volumes would be strange, but you can easily just not implement that capability and still get all the features except for that reconcile function. The per node limits seems more problematic, because I can totally see that, if you set the number too low, then you're going to run out of volumes on your nodes, even when you don't need to. But if you set it too high, then things will actually break. The only solution I see to that is to either redesign that feature, the CSI spec layer, or go back and split your driver up into 2 or more drivers that each have the correct limit, and that's really, really hard and really, really bad, and I wouldn't recommend it to anybody.
I want to briefly discuss that option also, like how hard it is to actually split the driver. Like, can we, like, for example, if like we know that certain features of some drivers are broken because of this using the same driver handler name, and if we had to like freeze that driver in time, that okay, you can keep using this driver as you want, but certain feature won't work. But if you want to use the new feature, like like maybe faster FS group application, faster SLNX support, and those things, then you had to change your handle to this one. So is it like feasible that we start encouraging a spec from the starting from spec side to like to encourage driver authors to basically split their drivers?
I'm trying to understand what exactly your proposal is. You're saying make it possible to change basically the driver name in the PV object?
Not really. I'm proposing that, okay, I'm thinking out loud rather than proposing at this point, but like there are certain, like for example, like I'll just take Azure file again. Azure file, one driver supports CIFS, NFS, and block board. That's just too many features. And some of them are broken to certain degree. vSphere CSI driver supports read-write many and this thing, and some features like, for example, node attached limit doesn't work for read-write many volumes currently. It doesn't report anything, or it doesn't work as expected. So what I was suggesting is, can we have this thing that, like, okay, these drivers can keep working as they are working today, but if they want to be more robust, get SLN support node limits, node attached limits, support like more newer features that are possibly still alpha or beta, they have to update to a new driver name. So it's like, I'm proposing that how hard really it is to freeze some drivers in time.
Yeah, yes. So we could. So our driver, I think, is called like trident.csi.netapp.io or something, and we could totally in the next release have two different driver names. You know, like NFS Trident and iSCSI Trident. And every volume you created from that point forward could use the new names. Like that is totally possible. The problem is, for all your old volumes, what do?
I mean, they keep working using existing mechanism. They just
but then you need a third driver, right? And now you have two new drivers plus the old one that still does all the old stuff, and you have to maintain it forever. And that's not acceptable to any development team, I don't think, to say, yeah, you got to build this new thing, but you can't drop the old thing because there's no migration path.
Also, storage classes become difficult, right?
Sorry.
Like if you have like an NFS and a block class today, then with like the third driver model, like managing the storage classes could also become challenging.
Ben, why do you need third driver, by the way?
Why? Because of all your existing volumes that you have the existing driver name.
Yeah, so they work with the old driver, right?
Right, but if the path forward is to actually split it out and have separate drivers, now you need a new iSCSI driver and a new NFS driver and an old legacy driver that does both iSCSI and NFS. And you can't ever get rid of the old one. That's the problem I see. If we could provide people a bridge to get off of a unified driver onto two separate drivers, and a way to properly deprecate and get rid of the old legacy driver, I think some people might cross that bridge, and it might solve a lot of problems. But today, unfortunately, like the driver name in your PV is immutable, and you can have very old PVCs that are attached to pods that have been running for a year or more, right? And you still need to be able to detach that pod someday. And it was attached by the old driver. And so like you can't just go in and say, well, I'm going to change the PV and stick in a new driver name and expect it to work, because the new driver implementation might be totally different than the old driver implementation. So you basically have to keep that old driver around so that it can detach that volume when that pod eventually dies. And given how long pods can live, that's a real, I mean, it strongly incentivizes people to just keep the same CSI driver name and the same CSI driver implementation forever, so that you never have to deal with the migration.
Yeah, no, I see your point. I think we should keep both options, like, like per CSI driver, per volume, like CSI driver objects, and maybe have a CSI, something in CSI that returns some more measure that which CSI driver instance to choose, and at this point on table, so that we can, like, I'm not sure which way to take. Yeah, Michelle, you were
Like
saying
other,
something.
yeah, I was saying, if we want to choose the path of encouraging people to have separate drivers, then one of the things that we should also consider, in addition to like trying to reduce the friction, is to find a way to help people migrate to the new model.
Yeah.
But do we also have the concern of like have too many drivers each time we have something similar, right? When you encounter this issue. And I noticed like a storage class, right? We have a map, like parameter that is can be opaque string, map string to string, whether we consider have similar parameter that each driver can have their own parameter and override certain fields.
What do you mean? I mean, those are the parameters in the storage class are all input parameters, and they're opaque to Kubernetes, but they're not opaque to the driver, right? So the driver documents what values are valid, and then it
we can also
them.
have similar way of documenting like what fields available. I don't think we have tons of like.
But where were you suggesting more opaque fields?
The CSI driver API.
Right. Well, you mean coming back from create volume, like the return value of create volume? Because
so the problem here right now, right? We don't have a way like to specify different value for certain fields. I'm just saying if we can provide a way to overwrite the value, let you to specify what value for certain fields.
But I feel like we have that where we need it, which is on the input when you're creating a volume. You can put as many opaque values as you want. And
Jing, are you talking about adding that parameter in the CSI driver? Is that what you mean in CSI driver object?
Yeah, similar way. Yeah, not exactly the same, like just a similar approach.
So every value in the CSI driver object is non-opaque because it's all consumed by kubelet and the rest of Kubernetes, right? Anything you add to the CSI driver object is to be consumed by Kubernetes, and therefore it can't be opaque because we have to document what each field means and how it's going to be interpreted.
Okay.
And yeah, so the basic issue here is kubelet is consuming these fields, but it can only, there's only a singleton of this object per CSI driver.
So when to consume it based on the different type, volume type, can it change to a different value when it's being created?
So like having some like key value pairs or something. This type is supports this, the other one does not, or something like that, rather than just one true or false, but we can define.
Yeah, if
parameters.
If Hemon's problem and my problem were the only ones we had, then I would say like, yeah, I can go off and come up with a proposal to like either change the CSI driver object or have multiple of them and a corresponding CSI spec change that would give us a hook that kubelet could then use to figure out what to do. That would be a fairly small change and not too painful, I don't think. But it would only address my use case and Hemon's use case. I think it wouldn't help Sandeep, and it wouldn't, and we would still be left with some of this weird grossness around, you send a create volume request and you don't know what you're going to get back.
Yeah, there's a this case like Azure File CSI driver is doing this stuff where like if you use NFS protocol, then it is doing recursive. The driver is doing recursive ch on ch mod.
Oh God, that's awful.
because it is because it receives FS group because it says it supports that capability, volume mount group capability, and that's only applied for CIFS protocol. But in case for it's like.
Now, Hemon, you remembered when I specifically said when we were designing this feature, nobody must ever do as recursive chown in response to this field being populated. You remember that, right?
Yeah. So the one challenge that we have in designing, like switching this CSI driver object based on the volume context, it might be tricky because we tried doing something similar with initially when we had this whether to apply FS group or not. We had this heuristic where if your volume is read write once and if you have FS type, then we recursively ch own ch mod your volume. If you have read write many, then we don't do it. But that assumption broke down in many cases, and Like maybe coming from CSI spec, if CSI driver tells us what to do, then maybe it will be more robust, but it was very fragile. So that's why we went ahead and added this thing in CSI driver object. So I'm just want to provide some historical context. So if you want to, like the switching the CSI driver object, it sounds like that proposal where it was dynamically determining based on access mode, FS type, but it could be, it could be, yeah.
Would you be open to a proposal to just make this FS group stuff a more proper CSI feature where the driver just told kubelet what it wanted to happen on a per volume basis, like as a top level CSI feature, and then and it's a new capability, and if your driver has it, kubelet just does the new thing, and we could just totally not rely on this FS group field of the CSI driver object anymore? Is that, like, would you be open to that as a solution?
It could work, but it just helps FS group, not like SL Linux and anything else.
Oh, right. I mean,
yeah.
So one of the nice things about the CSI driver CR is that it's sort of a wormhole where we can just add Kubernetes specific features quickly without having to change the CSI spec, because changing the CSI spec is slow. You know, you got to get community agreement, you got to go through alpha, GA. It takes time to do the releases and all that. So of course, there's always this temptation to just do the easy thing, add a field to the CSI driver object, and then implement your feature purely in Kubernetes. And I don't want to take that away, right? Because that's a nice hack to be able to leverage. But in this case, the hack got us into trouble because it was a bad hack, right? The heuristic is not right often enough. So that suggests to me that we for this one at least, we should do the right thing. But yeah, for stuff like SE Linux, should we do the proper CSI spec change, or continue trying to just do some hack based on the CSI driver object and hope that we can get it right on a per driver basis, or do we have to have a way of, you know, sort of on a per volume basis saying which CSI driver object to use?
I gotta say, I have similar feelings to Michelle, where I think we might be playing whack-a-mole with this thing, where there might be attractive short-term solutions that fix, I think, some subset of issues, but we would really need to look at this more holistically and kind of, like Michelle said, feature by feature, what do multiple driver approaches need from each feature? And that seems very daunting to me. So her proposal of, you know, instead of going down the path of let's make multiple drivers into a single driver work, how about we make it easier to run multiple drivers? So if you, I think there was two problems that I heard. One was, you know, deployment of multiple drivers is a pain. So if you could have a shared, you know, set of sidecars for multiple drivers, that could ease the pain. And the second thing I heard was migration is a nightmare, right?
Well, it's impossible. It's impossible to migrate without killing your pods.
I think there has been I know some people have been able to like basically re-import PVs without downtime. I think it's been done. But
yeah, well, we like NetApp wrote code when we moved from our dynamic provisioner to CSI to go through and basically rewrite all your PVs to, you know, they used to be NFS and iSCSI PVs, and then they became CSI PVs. And of course, we have a script that just goes through and does that. The problem is it only works on unattached PVs, right? If the PV is attached, you can't muck with it because you have to it has to be detached by the same thing that attached it. And so the only way to get rid of the old code is to kill the pod and do the detach and then reattach it with the new code.
If you had a new driver come up and say, I know what that volume is, and the old driver was effectively deactivated, from the volume perspective, nothing would change in that regard, right?
Well, you would need a weird mapping mechanism then in kubelet to say, like, okay, I'm detaching this volume with this driver name, but that driver is gone, and so I'm going to send it to somebody else.
Right.
Right.
That's the sort of thing that I'm thinking, might actually be easier, or maybe not easier, but
Oh,
smaller scope.
I was going to say that sounds huge, but it does sound feasible if that's the path people want to go down. There's a third path aside from sort of the gross hacks we're talking about, and Michelle's proposal to more strongly encourage separate CSI drivers, which is we could go through the CSI spec and fix all the specific areas, just to have CSI drivers be able to tell the CO, Kubernetes in this case, what to do on a per volume basis. It would be a bunch of new capabilities and a bunch of new fields, but it would be purely backwards compatible, right? The default behavior would be do what we do today, but we could have new behavior where if the both Kubernetes and the CSI driver supported this future CSI spec and the capability was asserted, you just be able to say, okay, what should I do for this volume? And you could just implement it correctly then. So that seems like the third possible direction. Yeah.
Can we look into a way of like this is a crazy idea, but can we look into a way of two things we can do is like relax the requirement of making PV driver name immutable. It'll be hard, I know it. And alternatively, rather than keeping a mapping, I wonder if we could, basically one is relax the requirement that where you can never ever change the driver name in the PV, or can we provide a way to override the name via annotation in the PV or something similar? How is that? So that you can migrate these PVs.
I don't think change. I mean, it's perfectly easy to just delete the PV and create a new one with the same name, and basically mutate all the fields you want to that way. The only problem is that doesn't work for attached PVs, and so you would need some sort of a.
But the many cases of driver update also essentially requires you to like go through like drain the node and start back up. So it's like that seems, for example, like when you upgrade like a cluster, like from in OpenShift, for example, like the nodes could be drained potentially. You still don't lose your entire replica set, or you don't lose your stateful set, but you could have your stuff moved around. So
for many people, draining their nodes and bouncing their pods is no big deal.
Yeah,
but we have enough customers for whom like that it is a big deal, and you don't want to.
But that's the Kubernetes. Like we cannot guarantee that your node will pod will forever be running on a node.
I know. I'm just telling you that there are people who have pods that have been running for more than a year, and they'll be very sad if their pod gets killed, and we have to deal with that. It's a bad practice, but it's real life.
Like I don't know, like the many cases, like the driver upgrade itself requires a drain actually. So yeah, I don't know if we could any solution we propose. Yeah, obviously it will require like it may require a driver the drain.
So there's one more downside to what Saad was just suggesting and with Michelle's proposal, which is if you do go down the multiple CSI drivers path, then any given storage class can only map to one of those drivers, right? Today, you can have a single storage class that is your default storage class that can cover both all your iSCSI use cases and your NFS use cases, just based on whatever the access mode is or the volume mode or other things that get passed in when you create a volume. If we said, okay, we're going to have two different drivers, one for NFS, one for iSCSI, it forces you to have two storage classes, and only one of those can be your default storage class. And so by default, all of your volumes are going to be only one of those drivers, and the other one would only be accessible by opt-in. And that would be a regression from current functionality.
Yeah.
Another idea is to have a default storage class per access mode.
But it's not only the access mode that matters, right? It's the volume mode,
FS type.
FS type. Well, the FS type is also defined in the storage class, but the volume capacity, like conceivably, we can give you a different volume based on how big the thing you asked for is, right? If you ask for a 2 terabyte thing, we might say, you know what, that's going to be an NFS share, not an iSCSI line.
I mean, it is feasible today for like, if there's a, you know, if a driver really wants to provide like really advanced storage class routing like that, like it could be done as an admission webhook.
Yeah, I mean, we could redesign everything, I guess, to go around, you know, that would basically be overriding the whole default storage class functionality and saying, okay, if they don't specify the storage class, there's going to be some controller that will look at the request and fill in the storage class on the Kubernetes side before it ever gets to the provisioner sidecar.
I mean,
right.
Okay. From
That could work, but that would be a significant redesign of a lot of stuff.
Is that like how like in practice, like for and at least in OpenShift, I can only say from our we install different storage classes for different types. Basically, we don't, because even though a driver supports multiple types within the same this thing, we install different storage class, so you don't end up like always having one type with everything. So it's, I don't know how big of issues the storage class thing is in practice, but yeah, like it might be bigger for NetApp customers, but for us it was okay.
Yeah, I'm not saying I love how things are today. I'm just saying that some people have come to expect things the way they worked, how they do today, and if we change it, it's going to cause friction. And I'll tell you that the internally our scheduler is very dumb, right? We filter out everything that we know isn't going to work, and then we start trying to create the volume on each back end internally, and then if it succeeds, we declare success, and if it fails, we go to the next one. We go through a loop until they're all done. And so it's very robust because we never give up until you literally can't create the volume anywhere. But yeah, the behavior you get is sort of hard to understand from the outside, because where your volume gets created really depends on what's going on the underlying storage and who had space and what things had the right, you know, could match the policies you asked for. And trying to do that all, you know, up above the CSI layer in Kubernetes with some sort of a admission controller would be a big challenge, because sometimes you just don't know who has space until you actually try to create the storage and find out that there's not enough space.
Okay, we are almost closing to the hour, so we should, so we should
I feel like we don't have a decision, but which is fine. But what I will do, because it doesn't look like anyone was taking notes, I will write up my notes from memory of what the issues are, what the proposals were, and I'll put them in this document. And I guess maybe we'll send out another email saying, you know, what the outcome of this discussion was. But it feels like we're going to need some further discussion, either more meetings or some sort of follow-up.
Yeah, I think we definitely need more than one meeting for this to cover the.
Yeah. Are people in principle okay with starting a series in this time slot and maybe meeting again in 2 weeks or 1 week even, and trying to make more progress? Everyone's on mute, so I'm not getting any feedback.
I'm okay with it.
Yeah, I guess that's going to be my default proposal, unless we hear of a better suggestion, is turn this into a bi-weekly series in this time slot and meet up again in 2 weeks and try to make more progress.
Yeah,
so
if we want to make like more progress, I suggest just 1 week. Otherwise, 2 weeks.
Oh, yeah. Okay. Well, yeah, I guess that's a good point. We could do it just the very next week. I just got to check my calendar, make sure that slot is free, or clear the slot if it isn't. But yeah, we can meet up in 1 week and we can just keep going weekly until we have a sense of what we actually want to do, and then we could dial back the frequency of the meetings or cancel the series altogether once we have some kind of agreement. But yeah, for now, I will I'll wrap up the meeting and I'll put my notes in the document and we'll schedule a follow-up next week, unless we find out that unless we have a different idea that's better. All right. So thank you everyone for attending. If there was anything that anyone else wanted to say and didn't get a chance, you can still put it in the document, and we can bring it up next week. Thank you all.
Thank you. Thank you.
How do I stop? There we go. Okay.